Hi everyone. So today we're going to be discussing a question which involves a lot of areas of calculus. We're going to be talking about limits, L'Hopital rule, which is probably the most important thing that you need to know when it comes to limits, and the fundamental theorem of calculus. We're also going to discuss a little bit the indeterminate forms when it comes to solving certain limits and how you can maybe figure them out. So yes, this is a very interesting question as it kind of involves all of these different concepts all in one question, right? So let's get started. This is a question from the Stanford Math Tournament in the year 2018. This is again a college math contest for high school students. And in this video, we're going to be mainly looking at limits of the form 0 times infinity, which is what the question is based on. And then we're going to look at the L'Hopital rule and limits of the form 0 by 0, infinity by infinity. And maybe we'll also talk about some of the other indeterminate forms, right? Just a brief overview of them. Then we're going to be talking about the fundamental theory of calculus, then obviously book sessions for senior math Olympiads, and at the end, a similar Chachik problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so the goal is to evaluate this given thing, right? Now this looks quite complicated. Let's just maybe break it down into parts. So really what it is, right? So it's limit as n tends to infinity of some quantity. What's that quantity? It is n squared multiplied by an integral. Integral from 0 to 1 by n of x is to the power 2018x plus 1 dx. Okay, great. Exam happened in 2018. We have 28 in the question. Probably it has nothing to do with the question as well. You never know. Many a time they just put it in there and it has absolutely no relation to the solution. It could just be any random number. But okay, regardless, what do I see over here? Whenever I see limits, I first see what form of the limit it is. So when limit is tending to infinity, n tends to infinity, maybe just like plug in infinity wherever n is, right? So n squared will obviously tend to infinity times this integral. Now, if n tends to infinity, 1 by n will obviously tend to 0 because 1 by infinity tends to 0, right? So 1 by n is essentially tending to 0. So this is an integral from literally 0 to 0 of whatever quantity we have inside. And an integral from 0 to 0 is obviously 0, right? Right? An integral from 0 to 0, what is integral? Essentially, for example, if this is a curve, and this is, let's say, a point A, and this is, let's say, a point B, the integral of f of x dx from point A to B is basically the area under this curve, right? This is the area of this curve. This entire area between these 2 points is the integral. Now, if these 2 points are basically 0, if both of them are 0, right? If both of them are 0, no matter what the integrand is, this will obviously be 0. So we are looking at an infinity times 0 kind of a format, right? Obviously this thing tends to infinity and this thing tends to 0. This entire integral tends to 0 because the limits are between 0 and 0. So we have an infinity times 0 format. Okay. Now this is one of the 7 indeterminate formats. Okay. Indeterminate forms. 7 indeterminate forms. And what are these indeterminate forms? We have 0 by 0, we have infinity by infinity, we have infinity minus infinity, you have 0 to the power 0. These are like 4. You obviously have infinity times 0 or 0 times infinity. You have infinity raised to the power 0 and you have 1 raised to the power infinity. So these are the 7 indeterminate forms that we have in limits. Indeterminate is quantity that cannot be determined, that you can only take their limits. So infinity times 0 is an indeterminate format. How do you evaluate them? So we have the 7 indeterminate forms. We transpose all of these remaining 5 into 0 by 0 or infinity and by infinity. So basically, if we have 0 by 0, it is great. If you have infinity by infinity, it is great. Why is it great? Because they are easy to deal with, and I'll tell you why they are easy to deal with. So if you have 0 by 0 or infinity by infinity, that is perfectly fine. That's great. If you have any of these other 5 terms, any of these 5 indeterminate quantities, You need to convert them into 0 by 0 or infinity by infinity in whatsoever way you want. In any which way possible, just get them to 0 by 0 or infinity by infinity and your work will be simple. Why? Because whenever we have limits of the form 0 by 0 or infinity by infinity, we can use L'Hopital rule. Right? We can use the L'Hopital rule. So what does L'Hopital rule says? So for example, we have limit as of, let's say, some quantity f of x divided by g of x as, let's say, x tends to some quantity k. And this will be equal to the limit as x tends to the same quantity k of f prime x divided by g prime x. So when you differentiate the numerator and the denominator, they are basically the same. The limit remains the same. The equality sign remains. And this is only and only applicable if you have a 0 by 0 or infinity by infinity format. So f of x and g of x both need to tend to 0 or they both need to tend to infinity. Then you can essentially differentiate the numerator and denominator and figure out something, right? Figure something out. One of the most classic examples of this is limit as x tends to 0 of sine x over x, And what you will do is essentially differentiate the numerator and denominator. So limit as x tends to 0 of sine x by x is the limit as x tends to 0 of derivative of sine x is cosine x, derivative of x is 1, and cosine x tends to 0 will obviously be 1. So this limit is 1. So you can see how easy it becomes. And this I could use because it is 0 by 0 format. Why? Because when x tends to 0, this becomes 0. And when x tends to 0, sine x tends to 0. So it's 0 by 0 format, I could very well use the L'Hopital rule. The underlying objective is that whenever you have 0 by 0 and infinity by infinity, please use L'Hopital rule. That will really simplify our life a lot. And whenever we have any of these other 5 quantities, try to kind of transpose it into 0 by 0 or infinity by infinity format. Okay, perfect. Let's move on to the question. Enough of that. So we had limit as n tends to infinity of n squared times this 0 to 1 by n of x is to the power 2018 x plus 1 dx. So again, this is infinity times 0 form. How do you transform infinity times 0 to 0 by 0? Well, infinity can be written as 1 by 0. Right? Because what is infinity? Infinity is nothing but 1 by 0, right? 1 by 0 tends to infinity. Or I can say infinity tends to 1 by 0 or 1 by 0 tends to infinity, whatever you want to say. So if I can maybe write this infinity as 1 by 0, my job is basically done. So how would I write that? I'll write that as the limit as n tends to infinity, the integral from 0 to 1 by n of x is to the power 2018x plus 1 dx divided by 1 by n squared. Now if you actually note the denominator when n is tending to infinity, in the denominator 1 by n squared will tend to 0, right? As n tends to infinity, 1 by n will obviously tend to 0, and similarly 1 by n squared will also tend to 0. Because 1 by a very, very large quantity will obviously tend to 0, right? So denominator is tending to 0. The numerator, it is as it was before. This 1 by n quantity will tend to 0, and therefore the entire numerator will tend to 0. So therefore we have now transposed this into 0 by 0 form. And now we can use this L'Hopital rule. So y is the limit as n tends to infinity of this integral 1 by n x is for 2018x plus 1 dx divided by 1 by n squared. And then you differentiate the numerator and the denominator. How do you differentiate the numerator? By using the fundamental theorem of calculus. And I think by now you all should be pretty much comfortable with that. So when I differentiate the numerator and denominator, what will I get? Limit stays as it is. Nothing changes to the limit. But you just differentiate these two functions like individually, right? Do not use the quotient rule over here. Quotient rule is not to be used. That's a very common mistake. Now, when you use the fundamental theorem of calculus on the numerator, what will you get? Pretty standard. 1 by n raised to the function, right? 2018 by n plus 1. Just plug in 1 by n wherever x is there. And because you have 1 by n and you're differentiating with respect to n, you also need to use the chain rule. So this becomes negative 1 by n squared. and the denominator then becomes negative 2 by n cubed, because the differentiation of 1 by n square is negative 2 by n cubed. Okay, great. How can we maybe deal with this? Let's just simplify this using computation. So limit as n tends to infinity of 1 by n raised to the power 2018 by n times 1 by n times negative 1 by n squared divided by negative 2 by n cubed. So effectively this negative and negative gets cancelled. N cubed and n cubed gets cancelled. What are we left with? So the y is nothing but 1 by 2 limit as n tends to infinity of 1 by n raised to the power 2018 by n. And we need to find out y, right? That's what we need to find at the end of the day. And how do we go about that? So y is nothing but 1/2 the limit as n tends to infinity 1 by n raised to the power 1 by n, and this entire thing is raised to the power 2018 because powers get multiplied in exponents, right? So essentially it's the same thing. Now if I can just replace x with 1 by n, or rather 1 by n with x, I am making the substitution. I'm putting x as 1 by n, right? Now when n tends to infinity, 1 by n would tend to 0. And what is 1 by n? X. So x obviously tends to 0, right? So we would have y is equal to 1/2 limit as x tends to 0 of x raised to the power x, because you are substituting 1 by n whole raised to the power 2018. Right? Okay, great. So how can we evaluate this? Now for those of you who are comfortable with limits, you very well know that this quantity is 1. For those of you who do not have that background, I'll just prove it. It's quite easy actually. So my claim is that the limit as x tends to 0 of x raised to the power x is 1. This is an indeterminate format of 0 to 0 form. You need to convert this into 0 by 0, infinity by infinity. Come what may, we need to get it into that format. I don't care how, just somehow get into that format, right? Now notice that x raised to the power x can be written as e raised to the power the natural log of x raised to the power x. It's the same thing because we have log to the base e, and that is essentially x raised to the power x. This is the standard property of logs that we know. So x raised to the power x can be written as e raised to the power x times ln x. And now let's just take the limit. So limit as x tends to 0 of x raised to the power x will be the e raised to the power limit as x tends to 0 of x times ln x. And maybe let's just analyze this. So limit as x tends to 0 of x ln x, because that's the major crux of it, right? Again, this is essentially 0 times infinity format. So how do I deal with this? I just write it as ln x divided by 1 by x, right? Standard form. And then you again use L'Hopital rule. Differentiate the numerator and denominator. Ln x becomes 1 by x. And this obviously becomes negative 1 by x squared. So this obviously becomes 0. Right? X is remaining and x tends to 0, so it obviously becomes 0. So my point is that this thing over here, this entire thing that I've written in a box, is essentially 0. So limit as x tends to 0 of x raised to the power x is e raised to the power 0, which is 1. So yeah, that's how you would prove it. And now this entire thing becomes 1. So y is nothing but 1 by 2 times 1 raised to the power 2018. So y effectively becomes half, and that is the answer. So like we saw, 2018 really had nothing much to do with it. You know, it really doesn't matter if it was 2018, 2020, 2022. It didn't really matter. Like I was saying before, it may matter in certain situations, but here it didn't, at least. But apart from that, I hope you like this problem. It was quite an interesting mixture of a lot of things. We used fundamental theorem of calculus. We learned about L'Hopital rule, the indeterminate forms, the 7 indeterminate forms. How can you maybe deal with some of them? 0 by 0, infinity by infinity, without thinking, we'll always use L'Hopital, right? If any of these other 5 forms, please convert them into 0 by 0 and infinity by infinity, and then use L'Hopital, right? Don't use it directly. You will get some extraneous results. And we also saw 0 raised to the power 0 form, which is again very interesting because you have this nice little manipulation where you're converting them into logs and then figuring out the limit. So yeah, I really hope you learned something from that, and let's move on. Okay, so we have some book suggestions for Senior Math Olympiads: Elementary Number Theory by David Burton, Problem Solving Strategies by Arthur and Gell, Functional Equation by Venkatachala, Problems in Plane Geometry by Sharigan, Elementary Number Theory by Sierpinski, Graph Theory by Harari, and Combinatorics by Brualdi. Okay, so at the end we have a simulable charging problem, and I want you to prove that the limit as n tends to infinity of the integral of cosine raised to the power n1 by x dx from the limits of 0 to 1 is 0. So we'll try this out, another interesting question, and if you're able to make any progress on it, let me know in the comment section. Until then, I'll see you in the next video. Thank you very much and bye-bye.
Cheenta programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.